Okay, so we'll go ahead and get started here. 4, 6, 2.
How'd that feel, Brindley?
So we have just one row that has an odd, no, they're all even numbers, 2, 4, and 6. Got 4, oh, they're all, that's right, okay, so they're all even numbers. We got 6, we got 4, and then we got 2. Okay, so that, I was thinking that we had an odd number here in the middle, but we'll go ahead and stick with that anyway. Okay, so with that being said, we are starting in the middle. Okay, now, left or right? Yeah. Okay, so then, all right. I can't stress this enough. You keep referring back to this, and that's fine. But eventually, the best thing that I can pass on as advice is note cards, okay? Or scratch sheet of paper. I mean, are you going to be able to look at this and memorize and memorize and memorize? Maybe. But then once we're done, you're going to end up like, oh, the imaginary, I can never remember.
Bing bong,
Bing.
bing bong.
You're going to end up like Bing Bong. This information is going to end up like Bing Bong. It's going to go down into all of those fissures, because that's really, I think, what that movie is trying to illustrate is all the different fissures of the brain and all of those little different, they call them recall tubes, which, no, was it recall tubes? Okay. Which I like to describe as just like this file cabinet, okay? Whether you say sophomore, freshman, or freshman, sophomore, junior, senior year, you have to find the right drawer, just like how it's categorized in your brain. Then once you find the drawer, you pull that out, you find the correct file, and then once you're in the correct file, find the correct document. So that's how this recall information is very similar to what I think they're trying to depict or illustrate in Inside Out. Okay? So nonetheless, we had picked the left side. And again, knowing what something isn't can help you associate what something is. So in other words, we know if we're asking about a polypeptide hormone or an amine-based hormone, and then there's 2 more classifications. What were they? So we just said polypeptide and amine-based. So how many more classifications are there? Okay, and what are those? Amino acids. And see, I can't do that. And then cholesterol, which means steroids. Okay, so once you have associated, you know that aldosterone is not a polypeptide-based hormone. Okay, so it's, again, categorizing that and writing things out on note cards or scratch paper. That's just a suggestion. Now, whether you choose to do that, that's entirely up to you. Okay, so we haven't done this in a while, so how about a polypeptide? That's probably too, what do I want to say? That is too difficult of a question. That would be for anybody, okay? So what is it that is a positive feedback mechanism? It is. Epinephrine is part of a yes, and it's an amine-based hormone, but it's also a positive feedback mechanism. I wished I would have shut the overhead off, but that's okay, because I just have it in sleep mode. Because if I just leave it like that too long, it's going to end up shutting off. But anyway, you said epinephrine, okay? So then, where are we going next? Okay? So then, what are some functions of that epinephrine? Yeah, and it does that. And so we would say that this epinephrine is really preparing yourself for a stressful situation. That's not the case with norepinephrine. Okay, that still raises your cardiac output, your heart rate, and everything else, just like epinephrine does. But where are we going next? Okay, so we're talking about norepinephrine. So it's not an entire body preparation for what we call that flight or fight response. Norepinephrine does something just a little different. We just said it's raising your heart rate, it's raising your blood pressure, but it's raising it to send to what specific spot? And yes, that is a tough question. Say that again? Yeah, it's sending it to your brain where that blood is certainly needed. It's not that epinephrine doesn't, but this norepinephrine would be longer lasting. Now, where are we going next? Okay, so then when we look at these two hormones, norepinephrine and epinephrine, one of them is a vasoconstrictor, one of them is a vasodilator. So pick one of those two. Okay, then where are we going next? Oh, I should say, okay, so which one's a vasodilator then?
Vasodilator would be norepinephrine. No, it'd be epinephrine.
It would. And you did catch yourself. Now, whether you did or your lab partner was shaking her head no. I don't know which one I saw. I think you caught yourself first, okay? Does anyone have a problem keeping that separate? Which one's a vasoconstrictor, which one's a vasodilator? Do you want what I think is something that could help? Okay. No one wants to be constricted by a snake, right? Who doesn't like snakes?
Me.
Okay. So, nor would you want to be constricted by a snake. So norepinephrine would be a constrictor. So nor would you want to be constricted.
Maybe you could be like it constricts and it's going to one spot.
And if that works for yourself too. Okay, so where are we going next? Okay, so then we talked about positive feedback mechanisms. We already mentioned over here, we had said epinephrine was picked, and we talked about norepinephrine. Both positive feedback mechanisms. There's one more. What hormone might that be?
Positive? Which one's positive?
Yes.
Wait, which ones did we name already?
Epinephrine and norepinephrine.
Oxytocin.
It is oxytocin, okay? Because one of the things that we had talked about, and remember, that's what happens with pregnant women and pregnant mammals, is what that hormone is going to cause uterine contractions to amplify and continue until basically an enzyme causes that to stop, okay? So until the child or the offspring, whether it's a piglet or a calf is born, whether you're talking about mammals or humans, or the baby, those contractions just continue to amplify. That's right. We sometimes also refer to oxytocin as a feel-good hormone, and we're seeing that in this movie. I'm forgetting the name of it. Yes, thank you. I Still Believe. And what happens is when you spend time around someone that you really, really enjoy, oxytocin is another hormone that we sometimes consider as a feel-good hormone because it's how mammals and humans bond with one another. It's just something that says, I really like this person, and that is just something that's released into the bloodstream and then as well. I'm going to open this screen for just a little bit, so then we wake this up and then we'll come back to it. So we left off with who? McConnell? So where are we going next? Okay. I guess we could probably just leave this as a blue screen. That ain't going to hurt anything. All right. Am I blue? We told a funny. Okay, anyway. So, all right. Name a steroid hormone that is also a mineral corticoid. So there's only 4 that we've talked about. It is aldosterone, because what happens is aldosterone causes the kidneys to conserve some sort of mineral because it's a mineral corticoid. And that mineral is what? Okay. And then the water just follows the sodium. That's just how the man upstairs designed us. Okay, where are we going next? Okay, so then I don't know why it just made that computer made that sound. All right, so what is, name one of the 2 negative feedback mechanisms. In other words, what is it that's being controlled by this negative feedback mechanism? You don't even have to give the hormones. That is kind of a tough question, but it's just one. In other words, remember we said like teeter-totters. It's something that once a stimulus takes place, how is it that it's going to be regulated to go back to a homeostatic level? Okay, so that does answer the question, but what is it that it's controlling? What is it that it's controlling? Okay? Yeah, well, so that's the other hormone now. So what are they controlling in the blood? Yeah, the calcium levels. That's right. So that is a negative feedback mechanism. That is true. Where are we going next? Okay, so then what are the 2 cells associated with the other negative feedback mechanism, which means it has to deal with sugar levels? So it's not the hormone, it's the cells that secrete them. So it'd be insulin and glucagon, but what are your 2 cells that secrete those? We used egg as a clue. So it's glucagon would be, that's the part in egg. So then it's what type of cell then? That is one. What's the other one? Beta. Okay, so the beta cells then will secrete the insulin, where the alpha cells will secrete the glucagon. Okay, where are we going next? Okay, so we just mentioned this insulin and glucagon. They're hormones that originate in the pancreas. Where is the target organ for those? What organ would actually help control that? What is it that's going to convert these glucose molecules into glycogen? Because that's what glucagon is telling it to. It's the largest gland. Yes, that is a tough question. In other words, it rhymes with the classification of these, like the Nile, the Mississippi, the Rhine, the Rhone, the Missouri. Those are all what? Okay, it's the liver. So those are all rivers, and it rhymes with that of liver. So yes, your liver is what's going to actually help you control your blood sugar levels to a homeostatic level. Where are we going next? Okay. So then, So I'm looking at my note cards and this handout as well. And let's go with, we know that thyroid stimulating hormone will actually cause something in your thyroid gland to be released. And what are those two hormones that it's thyroxine, but what's the difference between those two versions of thyroxine? Yes? Okay, so T3 is more potent, and then T4. So why is it that T4 is more common in our blood then? Well, and it's not that it's being made. It's just easier to transport. It's more stable. And yes, that was a tough question then as well. And some of you say, oh man, my question was a lot tougher than the next person. Well, yeah, maybe that's true, but we don't really keep score on here, okay? And where are we going next? Then I think we've got 2 left, okay? Then, let's see here. We said we have somatotropin, okay? That also is the specific name for what that actually does. And it has, we talked about, has an effect on your bones, like in your humerus, your radius on ulna, but especially your femur, tibia, and fibula. It's causing your body to what? Yeah, it's also known as the growth hormone. That's what somatotropin is, okay? And then finally, okay, something will inhibit somatotropin, because if nothing inhibits that, we could theoretically just keep going and going and going, and that is not very beneficial because it's just too hard on the human skeleton. But I did happen to notice that in the sports world there's a college basketball player, I don't know where, but it just showed a picture of him and Shaquille O'Neal, and he's looking down at Shaquille O'Neal, which is actually kind of funny. I think he's like, is he maybe 7 foot? 7 is okay. I think he's 7'7". Okay, 7 foot 9 inches, and okay. Yeah. So anyway, so what's going to inhibit that growth hormone? Somatostatin. Okay. So it has to be a way that your body actually keeps that from being overstimulated. So the somatotropin or growth hormone causes your bones to elongate, your muscles to get bigger. All of that is true. But there has to be a way to slow that down, and that is the somatostatin that you had just mentioned. Okay, so again, hopefully we find this beneficial, okay? And then we're done watching the movie, so that is it.
No, we're not.
We're pretty adamant about that.
Yes, so turn it back on. They keep
Okay.
love bombing each other. It's good.
Okay, all right.
Yeah,
So,
it's teaching me that like all my situationships.
all right,
could easily
we'll catch up to you next time.